Problem 54, page 708. Here, it's an application to Gauss's law in the case of a infinite sheet, infinite charged plane. Here we have non-conducting sheets of charge are parallel to each other as shown in the figure. The sheet on the left has a uniform charge density sigma, and the right one has a minus sigma. We have to calculate the total field created by the system at the left side, at the right side, and between the plates. First of all, you have to calculate the field created by one plane, infinite plane. After, we calculate the total field created by these two plates. First of all, you know that the plane in general is a symmetric object. So we can use Gauss's law to calculate the total field created by a infinite plane. We have to say by symmetric we select a cylinder as let's say of radius r as Gaussian surface. Okay, you know this plate, let's take the orange plate in general. This plate is positively charged, so the field must be outward of the plane. To the right and also to the left, because it's a symmetric object. And here we have to choose a cylinder, let's say like this. We have the same section to the left and to the right, and we have the lateral side of the cylinder. Here, this side has a section equals to A, and the same one here equals to A. Okay? You know the section of A equals pi r square. A equals pi r square. R is the radius of the cylinder. And the area of the lateral side, let's say here we have the lateral side has A prime, okay? A prime equals to 2 pi r times the length of the length L of the cylinder in general. L is the length of the cylinder. So here we have, let's say we have side 1. Here we have side 1, side 2, and we have the lateral side, let's say side 3. I want to draw the A vector for each side. Here A is to the right, here A is to the left, and the lateral side, it will be perpendicular to, it will be on each side, perpendicular to the vector E. So here we have, let's say we have dA, okay, dA 3, and here we have dA, because dA1 equals to dA2. Let's say dA2 and dA1. Okay, in general, if we want to calculate the total flux created by the plate, equals to flux 1 plus 2 plus flux 3. In the case, in the lateral side, as you see here, dA3 is perpendicular to E, because E is in this direction. So the angle between equals to 90. So in this case, we don't have a flux through the lateral side. We can write flux 3 equals, okay, here, flux 3 equals to integral E dot dA 3 equals to integral of E dot dA 3 times cosine the angle 90. So we don't have flux in this direction. Don't forget to put the conditions where we use Gaussian surface. You must write E must be parallel to dA. Also, E must be radial, and the last one, E must be constant on the plane. As you see here, on the side 1 and on the side 2, E is constant. Here you see on the plane, E at this point is the same on this side, because it's at the same distance from the plane. The same for the other side. E is constant. So it's okay. Now we take A1, side 1 and side 2. These sides respect the 3 conditions. Okay. Let's continue for the total. So we have here flux 1 and flux 2. You see here the flux to the right side equals to the flux to the left side, because you have the same quantity of lines to the left and to the right. So we can say the total flux equals to 2 flux 1 or 2 flux 2 equals Q N divided by epsilon. Okay. Here equals to 2 flux 1 equals to integral of EdA equals Q N divided by epsilon. Okay, in the side 1 and side 2, dA and E are in the same direction, so the angle between equals to 0. We can say 2 integral E dA cosine 0 equals to Qn epsilon. Now, E is constant. We can get out E. The integral of dA equals to A. We can write the total flux equal to EA equals to Q N divided by epsilon. Let's take the left side, the 2 EA. This is the area of left side and right side. The area equals 2 equals pi r square. Okay, the area of the disk of the left side and the disk of the right side equals to pi r square. And Qn here, Qn inside Gaussian surface. You see here, inside the Gaussian we have this part of the plane. The intersection between the cylinder and the plane will be Qn, where the area of Qn equals to A. Look here. Here, if you take the cylinder, will intersect the plane like this. Okay? So, this has also area equals to A. In this case, because we have a surface charge density, we have to write Q equals to sigma times A. We substitute A and Qn in the equation. We get finally phi equals to, we can calculate E directly. We can say E equals Qn equals sigma A divided by 2 epsilon 0 A. We can cancel A and A. We get finally sigma divided by 2 epsilon 0. This is the field created by only one plate, one sheet. Now let's calculate the field of our system. The orange here is positively charged, and we have the blue one which is negatively charged. Okay, they have the same shape. Okay, the left one has a positive charge. Here we have sigma. This one is minus sigma. The positive charge, so the field must be created outward of the sheet. So it must be out in this direction and to this direction. Okay, the same like this. Okay, the blue one is negative, so the field must be inward toward the sheet. So it must be in like this. And here also it must be in. Okay, so here we have, let's take inward the plate. Okay, let's take the same for all the infinite sheet. Okay, look here. To the left side, here we have side 1, here we have side 2, and side 3. In the side 1, as you see, the field created by the sheet, the positive one and the negative one, are opposite. So each one will cancel the other. Okay, we arrive to the end. We don't have a field at this side. You have to say this is the side 1. We can say left side. We have the left side at the left side. The field the fields created by uh, by the sheets are opposite. So E total equals to E plus here let's say before the field created by the positive 1 equals to sigma divided by 2 epsilon. We calculated this value. And the field created by the negative 1 equals to minus sigma divided by 2 epsilon. So the total field created at the left side equals we have the opposite, let's say 2 epsilon 0 plus, we can say the opposite equals to 0, okay, directly. And the right side, we have the same result at the left, at the right side, the field the fields created by the plates are opposite. So E equals to 0. Here we have E left and here E right. But here between they have the same direction, we can add the values. Okay, we get here E total equals to here we have sigma over 2 epsilon 0 and sigma over 2 epsilon 0. We get here half plus half. The total will be sigma divided by 2 epsilon 0. Here the minus here, it means the charge, okay, the charge is negative, but about the value of the magnitude of the field, it depends the direction. We cannot put here sigma over 2 epsilon minus sigma over 2 epsilons. No, we have to add the values, the absolute values of each one, okay, because they have the same direction. We add, excuse me, the addition will be sigma over epsilon 0. If you want, you have to say here equals to sigma over 2 epsilon 0 plus minus sigma 2 epsilon 0. We get sigma divided by epsilon. Okay, this is the value of the field here. Okay.